In this video, we're gonna do the Laplace transform of square root of t over pi times cosine for square root of t. Given that the Laplace transform of cosine for square root of t over square root of pi times t is equal to e to the negative 4 over s over square root of s. And um, we're gonna need this formula right here to solve the Laplace transform of this inside function here. We have the Laplace transform of t times any function of f of t is equal to the negative e over ds of f of s, where f of s here is the Laplace transform of f of t. Now, first we're gonna need to change this inside function here into a format like this: t f of t times any function f of t. Now, to solve for this format, we're gonna need to eliminate the square root here. Now, since we know that square root of t is equal to t over square root of t, since we have put the t here because we want to express this inside function here the same as this format, so we're gonna need to put the t in the numerator. Now, what function or what term should we divide the t by to get square root of t? Now, since square root of t times square root of t is t, then we're gonna divide the t by square root of t. Now, we've already expressed the inside function in terms of t times f of t, and we'll write that one here. This is already t over square root of t, and we're gonna separate the square root of pi cosine for square root of t over square root of pi. Now, since we want this to be in the form of t f of t, then let's separate the t from f of t, and the f of t now becomes cosine for square root of t over square root of pi times t, because multiplying this square root of t times square root of pi, it's just square root of pi t. Now, since we've already changed the inside function in terms of t times f of t, where f of t is cosine for square root of t over square root of pi t, now let's equate that to negative d over ds of f of s. Now, what's f of s? Since this is our f of t and according here, f of s is just the Laplace transform of this f of t here, and the Laplace transform of cosine for square root of t over square root of pi t is just this. Then we'll substitute this one as our f of s. E to the negative 4 over s over square root of s. Now, we can write this rational expression here as the product of two terms, so that it's easier to take the derivative of this expression. We're gonna put e the negative 4 over s times s2 the negative 1/2. The exponent becomes negative because we have to bring the square root of s up, and square root just means 1/2. That's why square root of s 1 over square root of s is just s to the negative 1. Now, to take the derivative by product rule, first we'll copy this negative and we'll find the derivative of this expression. By product rule, e to the negative 4 over s times the square root of s to the negative 1/2 is negative 1/2 s to the negative 3/2, because negative 1/2 minus 1 is just negative 3/2, plus copy this s to the negative 1/2 times the derivative of this term. The derivative of that one is e to the negative 4 over s times derivative of the exponent 4 over s squared. Now, simplifying, we have copy the negative, negative e to the negative 4 over s over 2 s to the 3 halves, because to change this to positive exponent will bring this down, then remove the negative sign. That's why we have s to the 3 halves as our denominator, plus 4 e to the negative 4 over s over, we'll bring this down, s to the negative 1/2 becomes 1 over s to the 1/2, and s to the 1/2 times s squared is s to the 5 halves. Now, factoring out the e to the negative 4 over s, we have e to the negative 4 over s, and then multiplying negative here times negative here, we have positive 1 over 2 s to the 3 halves minus, because negative times positive, negative 4 over s to the 5 halves. Now, this is now our answer. That's all.